Dr. Gold in the lab, Twitch stream glowing, formulas flashing, minds wide, knowledge flowing, equations on the board, numbers never sleep, teaching math and physics while them haters count sheep. Actual education, tune in and get schooled, flipping textbooks, breaking all the rules, from Newton to Einstein, concepts elevate. Keep the stream, it's the key to our fate. Dr. Gold dropping gems, knowledge raining down, actual education making scholars all around. Perpendicular minds, angles sharp as ice, maths and physics, yeah, the future's real nice. Got the Pythagorean triangles about to flex, quantum theories on deck, breaking all the specs, relativity theories, worlds getting small, grasp the universal laws, standing tall. From the atom to the cosmos, we rolling deep, graving up the stars, no time to sleep. Black holes and supernovas, concepts we unfold, brain power heavy, yeah, that's Dr. Gold. Dr. Gold dropping gems, knowledge raining down, actual education making scholars all around. Perpendicular minds, angles sharp as ice, maths and physics, yeah, the future's real nice.
Not an AI raid. Wow, not an AI raid, he says. That's crazy. That's crazy.
Nice.
Wow, we got so many people on the fucking stage. What's up, everyone? Good to see you guys. What's up, Peach Tea? Party 15. Yeah, big shout out, Zach. Thanks, Zach. First time chat from Raider. Breskles, you've been... What? I'm glad, Breskles, you found a lot of the other math community. A lot of great people around here. And one of them is Eat the Try Pie. Let's go give him a big shout out.
Oh, yeah.
A big AI shout out. Oh man. Okay, great. Oh my god. All these texts and stuff, and I don't know, work, and I'm dealing with this shit later. No. Anyways, yeah. All right. What's up? Welcome. It is Tuesday. I have to check the day sometimes. AI is Actual Education's my next troll account. Apparently, like, Actual Education's dad has been like wrecking havoc in all the other math streamers. I'm like, that's not my account. Someone else is just pretending to be my dad.
Oh no.
Which I'm like, cool. I mean, the world needs more father figures these days anyways, so if someone wants to be another father figure, that's great. He did do an AI generated problem today. Oh, did he? Wow. Baby steps, Zach. Baby steps. We're getting you there. We're getting you there.
He very well may not have known it was that PDE question I threw in at the very
Oh.
end. It looked like we were about to run out of questions. I was entirely ChatGPT, and I was like, just give me an easy heat equation problem.
I appreciate it. Yeah. Thank you, Matham, also as well. Yeah. That's too funny. That's funny. Yeah, you did do an AI generated question. Uh-oh. You're getting your toes in the water at this point, dude. Dipping them in. Anyways, what was I gonna say? Blah blah blah. Yeah. Okay. Cool. News. Let's see. What's the news? News. Oh yeah. So we did have the final results from the Maddox tournament. Let me go find those. 1 second. Where are they gonna be? It's in our Discord. I made an announcement last night. I know I did. There we go. Cool. All right. Yep. So, Maddox Championship results are in. So, first place came Arya. Second place was Dot File, which was Star. So, congrats for you guys on the top 10. And then everyone else did really well as well, which was awesome. I came up with this cool scoring mechanism, also with the help of AI. Because there was the amount of points earned in all the different rounds were like really, really different. So, I made it ranking wise, but also kind of Mario Kart style. You know, you get like 18 points if you get first, and it's like 15 points if you get second. So I just had AI kind of like do that for me. So anyways, you guys did really well. It was just a really fun tournament. I appreciate everyone that participated in it. I think Zach, yeah, Mario Kart scoring, we love it. Zach, I think you would have liked kind of how their app works, because they also have a similar thing with like timing, and like you get points based on like how fast you answer it. It was really cool. So I definitely enjoyed it. I'm glad we got sponsored to do it. That's great. So I just have to wait. They have to send over the other half of the cash for it. But once they do, I will do a live drawing for the other two $25 prizes we have for just participating, and then also for making it into the top 10. So we'll do those probably at the end of the week, I think is what they said. They said they'd process it by the week. So also on Friday, we're going to do a chess tournament. So May 1st, it's going to be an hour earlier than usual because I got a dinner date.
That's dope.
Got a girl to say yes to dinner. Holy shit.
Oh shit, not good.
So we're going to do that at 5 o'clock on Friday. That'll be fun. Come on by. It's Blitz. Not Bullet. It's Blitz style chess. So 5 minutes, 3-second regen. And we'll do a $10 gift card prize giveaway at the end. So based on how many games you win, how many games you play, you get more chances on the spinner wheel. And then that determines who gets the prize. So even if you're not the best chess player, you can still win. We have this happen all the time, actually. People who maybe lose all their games end up winning the gift card. And so just because you're not the best doesn't mean you're not going to win. And just because you're the worst doesn't mean you're always going to lose. Oh, Actual Education's dad is here in the chat. Oh my god. Oh geez, did you cut the list off from 8th to 10th? Well, no. These are just the people that competed. So I was actually very surprised. So we had 10 people make it to the championship round, but then I needed everyone to show up at like a certain time, and we got 6 of y'all to do that. So I was very surprised, actually. I was like, this is great, actually, because it's hard to coordinate between. Some of you guys are all over the world in different time zones and stuff. So I did not reward myself. No, I got 4th anyways. So yeah, I said I was perfectly average. I'm perfectly fine with being average. Dr. Gold's changing up the sounds. Pokemon Family Feud. Yeah, you recognize all of them?
My man.
Nice. I do add some new sounds to the soundboard every once in a while. What's up, Justin? You're at an over-the-board chess tournament about to start the round. Oh, very cool.
Yeah.
Well, Justin, come by to our chess tournament on Friday if you want. All you have to do is make sure you join the chess club. There's a link here for like joining it. And so here, I'm already a member of this club, but once you join, I can accept you into it. And then the key thing is an hour before the tournament starts, you can register for the tournament. So I will ping you guys like crazy. I always do. Being like, hey, there's a tournament today. And then, hey, the tournament's going to start in an hour. Or, hey, it's going to start in 5 minutes. Like, please, just register. Swiss style just means that you play, like there are rounds, and you play everyone like kind of round robin style within the tournament. That's what Swiss is. There's also called like arena, which is you try to score as many points as you can in a certain amount of time, but then that kind of incentivizes finishing the games faster. So yeah, it's like last time. Yeah, exactly. Yeah, it's a Swiss tournament. It's just standard. We've had a couple of these actually over the, if we look at our club events, we've had a couple of them already. These are all the chess tournaments we've done. Oh, I can hit the more button. Wow. Even more. Look at all these tournaments we've done. It's pretty fun. Whoever suggested I do more chess, this is great. Why do we all not have our normal names like that? I don't know. Maybe someone set your name as baby code. That's actually interesting. Yeah, wait a minute. Wait, what? That's got to be a Discord
I think it's
error.
still like the Discord is using the actual like.
Wait, when did that happen? Why?
Legit user. I don't know.
Did something change?
It's like mine showing like the dot before my name. Or...
Sensation. Did something change in the Discord? Sensation's like our admin person. What happened? Maybe it's under. Oh man, I don't know what setting that is. Oh wait, server profile maybe. I don't know. Server tag. Members. Okay, whatever. I'll go figure it out. I think maybe some Discord's always changing stuff.
Oh shit, not good.
I mean, I'm sure I could Google it right now. It could be like Discord servers not showing.
Yeah, I think
What's
it
called?
just changed all of the
Not showing
server
nicknames, right?
profiles to be the just to be your actual like username, not your nickname.
Server. Oh,
'Cause
streamer.
I
mode.
was able to fix mine by just like going to my server profile and.
One second, let me go find this. Okay, go to server settings. Wait, you had to manually change it?
Yeah, I mean, it wasn't that hard for me because it was just.
But that's super
Two
annoying if
letters.
everyone in the Discord has to go change their name. Really? Oh, thanks, Justin. Good luck, good luck. Oh, there you go. Oh, yeah, so baby got it fixed. Yeah, I don't know why that is. That's probably a bug, honestly. I'm tempted to, I would say like randomly Discord server randomly not showing nicknames. Well, okay. Maybe there's just a, I don't know, maybe it's like a community error. Sometimes you can go like, well, this is like 4 years ago. I wanted something like recent. Anyways, I don't know. Yeah, okay. You should be able to change your nickname if you want to although I kind of recommend people to like keep something constant. It gets really difficult to remember who's who. When you guys go from, I don't know, like Big Balloon Ball 34 to Lipton Iced Tea 26 or something. I get so confused. Like, wait, who is this person? I get it. You're in the teenage phase of your life where you're having identity crises and you're trying to define like who am I, and so like picking the perfect screen name might be a process. Oh, you know what's actually interesting? Oh, I can see that now actually in the admin console. I can see it here. I can see dot breasticles is now breasticles. I think that's got to be a Discord bug. Wait, all these nicknames got changed? Who the fuck did this?
Yeah, it looks like it just like reset. all
What the hell?
the-
What the hell happened?
The actual like username.
Chunbyo is support to end at 14 per brain. I don't know what that means. Go check the logs. Okay. There's a lot of stuff that goes on in here. I thought this was the funniest. Someone changed their what was it? They changed their profile from like one like thing of Lipton tea to another like flavor of Lipton tea. I was like, what? Okay. All right. Anyways, so yeah, that's the news for today. I can check the log, server settings. What is it? Audit log. Oh, Sensation did it. Oh, Sensation. Sensation's trolling you guys. I see it now. Sensation changed all your own nicknames. Sensation, what are you doing to those guys? Come on.
Oh, hell no, man. What the fuck, man? Get your ass
Oh man. Okay. Funny. All right. Sorry, I have a little bit shorter time here on the stream because I got to go teach later. So, let me start. We got already 4 questions. Let's go help you guys out with math and science, and here we go. All right. Welcome on to Actual Education Office Hours. My name is Dr. Gold. This streamer helps you with math homework and science homework. Let's go live on the platforms. All platforms. I don't know why my chat's not working on TikTok. It just like sometimes doesn't decide to work. It's super annoying. I'm sorry, TikTok. You won't be able to see anything until they allow it to happen. Oh yeah, see, dude, I can see it, dude. What the hell? Just why is it not displaying? Okay. Whatever. I'll fix it later. It was for consistency? Oh, okay. Well, I think breasticles and breasticles with a period is kind of the same shit, so I don't really care about that. But yes, it would be nice if people stop changing their nicknames all the time because I get confused like who's who sometimes. Okay, let's see. Let's go to the queue. What do we got? Live queue, 5 questions. Nice. Let's go spin for a winner, see who we're going to get. And let's go.
Let's go gambling!
Who's it going to be? We're starting off with breasticles. Oh, man. At least you're getting me when my brain is fresh. Yeah, not towards the end of the stream when I'm like
this one's,
fucking done.
Terrible. It's just gamma functions.
He
and
says it's-
beta
it's not-
functions.
Oh, man. Gamma functions and beta functions, they say.
Yes, the two of them.
Alright, let me start this on. Okay. Nope, that's it. All right. Let's see. Ooh. Okay. This looks simple. I bet
Yeah,
it's
it's
probably
not that
deceiving
bad.
though. I bet it's deceiving though.
No,
It's
it's
gotta be
actually
deceiving,
like
dude.
really not that deceiving.
It's gonna get me, dude. This one's gonna get me.
I've really like scared you into thinking that they're all. Like,
Dude, well, because the
deceiving.
last couple ones have just like hurt me so much. They've hurt me so hard.
Yeah, that's because I was like, oh, I want them to be realistic. An
Yeah.
infinitely large rod, that doesn't work. That's
Nah,
not real.
just make it close enough.
No,
All right, here we go. All right,
So,
so
yeah.
tangent to the eye. Okay, first of all, I didn't even know you could raise things. I guess you can do e to the I power, right? E to the pi I.
Yeah,
Tangent to the eye seems
Right, then
interesting.
Yeah.
Do I want to put this in Euler form first? Is that what I want to do?
No, so actually, first, what you want to do is break it apart into cosine and sine terms.
I like that. Yeah, I'm a fan. Right, tangent is equal to sine over cosine. We love that. So I can say this is the integral from 0 to pi over 2. And that's going to be sine to the I x over cosine to the ix dx.
Yep. And then now you'll want to move the cosine up by saying it's right to the negative I.
Ooh, okay. I'm cool with that. Right, so we'll put this up. Okay. 0 to pi over 2. Sine to the I x cosine to the minus I x dx. Okay.
Yep.
And then is
And
this some like
then-
sum of sines and cosines?
I just sent in chat. We have this nice little identity here.
Oh, okay.
Beta
Just
function.
magic random just comes out of the air. Love when that happens.
Kind of. That's just like how we define the beta function. There's a couple different forms of
Oh, okay.
yeah.
So this is called the beta function. I don't think I've ever seen the beta function.
It's similar to the gamma function.
I know the gamma function. That's this thing, right?
Yeah,
Okay.
yeah. And it's it relates to the gamma function.
So in this case, what I have m minus 1 is equal to I. So
Mhm.
m is equal to I plus 1 for this one.
Yep.
And then it's equal to 1 minus I for the other one, I guess. Yeah.
Yep.
Okay. So this is. Oh no. Yeah. Same thing as. Okay. To the m. N minus 1. N minus 1, but here m is equal to I plus 1. And then if n minus 1 is equal to negative I, then n is equal to 1 minus I. Okay. So we have to try whatever the Edward Witten. Is that the guy that solved the Edward Witten? Where do I know that word? That is he like affiliated with like Penrose and stuff? I know that name from somewhere. Okay. I plus 1 over 2, comma, 1 minus I, all over 2. Okay, then we're done, right?
Not quite. We could
Not
get an actual,
quite.
Like, close one form. Then We also have another lovely identity relating the beta function to the gamma function.
Okay.
Which is that. This is like an identity workout, really. With beta and gamma
Where do these
function.
functions even come up? Like what is why would I ever see beta functions and gamma functions? Is this
So
a
gamma
PDE
functions
thing?
are helpful, at least in the case that the gamma function is an analytic continuation of the factorial. So, like, if you wanted to take half factorial, that would
Oh,
be
I
defined
see,
by the
I see,
gamma
I see.
function. Or if you wanted to take a negative factorial, as long as it's not an integer value, like -1/2 can be defined using the gamma function.
Here's some little quick cool things about the gamma function. So the gamma function works as an integral from e to the this looks like e to the negative n x to the n minus 1. Is that kind of what that is? Is that supposed to be
E
n?
to the negative x.
Oh, this dude's x's and these n's are terrible, dude. Oh, what? No, go back. Anyways. Okay. And also gamma of 1 is 1. Gamma of 1/2 is the square root of pi. And gamma of n plus 1 is the same thing as n factorial.
hmm
Oh. Okay, so yeah, if you had like a 1/2 factorial, that'd be gamma of 3/2.
Yeah, and then that is something that you can solve. Like, for example, like a little while ago, when my power went out, the question I submitted was about like the pigeonhole principle. That, for example, when it
how many pigeons can you put into like so many
and
holes
we
or
had
something?
to figure out like -1 factorial and show that 1 over -1 factorial evaluates to 0. The gamma function is like a way that we can do that. Because it's an annual.
Oh wait, this is like not a terrible integral to do either, right? This is just
it's
integration by
not too
parts.
Yeah.
Oh, okay, cool. Okay, so then we have these properties of what's called the beta function, which looks like it relates more like sines and cosines and stuff, and it does have relationships to the gamma function as described here. Okay, so I can rewrite this as 1/2 gamma of I plus 1 over 2 gamma of 1 minus I all over 2 and then over gamma of I plus 1 over 2 plus 1 minus I over 2. Okay, this will simplify at least, right? I got I over 2 and minus I over 2. Goodbye. That makes things a little nicer, right? We can get rid of this shit. And then I just have 1/2 plus 1/2, right? 1/2 plus 1/2.
Yeah.
So this is just the same thing as gamma of 1, which I think from what I saw here, right? Gamma of 1 is just equal to 1.
Yep.
Beautiful. Okay, this is just equal to 1. Sorry. This is there's a 1/2 out front. Okay, cool. So this whole thing is equal to am I going to do a double integral now?
No, we don't need to do that. So if you go back to the identity sheet over there on the right.
Yeah.
See how we
this?
have we can use that.
Gamma of n
just
times
saying-
gamma of 1 minus n is this? This is kind of the one I want to use, you think?
Yeah, hold up, let me send you a more clear form.
Because this is kind of like 1 minus this, right? I think it is actually.
Yeah, it's pretty similar. An easier way would be to
Oh, there's
say,
one with
right,
cosh.
this. Yeah, well, and that's just directly from the sine and cosine is just saying when we insert an I, it becomes a cosh.
Okay.
So we can use that.
Is that because the sine of I pi is the same thing as sinh of I pi, sinh of pi?
Yeah.
Oh, I don't think I'm. Oh yeah. Because the difference between like sinh and sine is like
Well,
whether
I
there's
think
a.
it's Yeah, I want to say it's cosh of I. I want to say it's cosh of ix is cosine of x.
Yeah, it's this. Sinh
Yeah.
of ix is I sine of x.
Hmm.
Oh, okay. So, but what happens if I put an I inside my sine? What happens? What if I
Yeah,
have an
it's,
I inside of? Oh, wait. If x is equal to xi, right? Then doesn't this become sinh of -1, negative x?
Yeah, it just goes back and forth, and you can always verify it by remembering that the formula for sine is e to the ix plus e to the negative ix divided by 2i. And
Yeah,
then you can just plug it into there.
I see. That
So
works as
yeah,
well.
you would get like a negative I out front, I believe.
Okay. Okay, so in this case, y is equal to 1/2. From what I see here, right? Because I'm gonna have 1/2 minus I over 2. So this is all equal to pi over the cosh of pi over 2.
Multiplied by 2 on the bottom as well.
Multiplied by, sorry, there is another 1/2 there. Okay, cool. And does this do anything nice? Is cosh of pi over 2 anything cool?
Let me check.
Is it equal to 0?
I honestly don't remember, but yeah, I mean that's the final solution. But let me see.
I know
here.
cosine of pi over 2 is 0. What's
Yeah, I don't-
cosh of pi over 2?
think there's a pretty value for it, but let me see. I've never actually thought about that.
Uh-oh, baby developer.
It's like
check your
2.509178 blah blah blah.
Okay, but it's not anything nice. Okay, cool. Nice. Okay, cool. That's it. This was actually. This is all I had to do. Oh my god, this is beautiful.
Yeah, I was
Wow,
like,
this is so
wasn't
nice.
that
I feel like I just got like the good cop, bad cop routine.
bad. Yeah, pretty much. I was like,
This one wasn't bad at all. I was like, yo, I like this.
Best of the days.
Alright, nice. Cool. Yeah. It's cool. It's cool to remember what sinh and cosh are. I'm briefly familiar with beta function stuff. We start with gamma functions, but I'd never heard of beta functions.
Yeah, they're fun to work with sometimes.
Where do you
Sometimes
mainly
it
see
gets-
them? Like what area of math?
I've seen them in like complex analysis, mostly, and then you can like kind of use it in statistics if you were like sadistic enough to be like, yeah, I just want to make
Oh,
every
no.
factorial of gamma function.
Yeah. But we
But
don't
I guess mostly complex analysis, I'd say.
Dope. All right, cool. Let's see. Let's go pick another question. So, anyone who's watching, if you want to submit a question to our stream, the website's right there, actualofficehours.com. Just go click on it, and we will put it into the queue. So, if we click here on the queue, let's see where we're at. Lucky Cat has the highest chance, 9 upvotes compared to the 6 that Equity has done. This is so fun. Okay, cool. Let's go gamble. I want to see who we're gonna go help. Let's go gamble.
Let's go gambling!
What's up, Gladiator? Wow, Lucky Cat is Lucky Cat. Lucky Cat is lucky today. Oh, I love these. These are fun. We're gonna do log questions. Love logs. Okay. Yes. Algebraically solve the following equation. State any restrictions on x. Okay, so the first restriction, anytime you're doing log of anything, is you can't take the log of 0 or like any negative numbers. So if we want to say like restrictions, here, I'll do the first one. The restriction right away is that x plus 4 has to be greater than 0. You can't take the log of 0 either. So that means x has to be greater than -4. Okay. Now, when doing these, I think we assume anything that doesn't have a number underneath it is log base 10. In Mathematica land, you actually assume anything log has base E. It's actually quite strange. But here we're going to assume it's base 10. I think that's what you guys do.
You do the same in complex analysis too.
Do you? You just say like log is log base E?
Yeah, because what ends up happening is you have two different logs. You'll have log with a capital L, which is a natural log and only considers your principal branch. But if you have log with a lowercase l, it considers all branches.
Oh, fascinating. Jeff says E is the natural log. All other logs are unnatural.
Oh hell no, man. What the fuck, man?
Anyways, okay.
Get your ass
So when doing these, you can put things in what I call like exponential form. So log base A of B is equal to C. The other way to write this is to do like A to the C is equal to the B. So if you were to write this, you get, oh cool, 10 to the 1 is equal to x plus 4. So that tells you that x must equal to 6. And you can kind of see that as well, because log base 10 of 10 is just 1. Anytime you're taking the log base of the same thing, you get 1. Okay, cool. Number 2, same thing you're going to do for the... So you actually have 2 restrictions here. Well, actually, interesting. Yeah, you do have 2 restrictions here. So x plus 5 has to be greater than 0, and also 2x has to be greater than 0. Okay, so, I mean, this doesn't tell you anything. Okay, so cool. X has to be greater than 0. Fine. And this tells you x has to be greater than -5. Okay, so which one covers both of these conditions? It's if x is greater than 0. You can't have negative values of x, even though they do work in the first log. They wouldn't work in the second one.
You're not that guy, pal. Trust me. You're not that guy.
Yeah, exactly. Yeah, they overlap. Yeah. So this is the restriction. Okay, so let's go figure this out. So the cool thing is, if you have 2 logs that are subtracting each other, you can write them as a single log where they're dividing on the inside. So I can say this is the same thing as log base 2 of x plus 5 over 2x. And this actually kind of shows some cool things to you, right? This is why x can't equal 0.
Oh no.
Because then you'd be taking like the log of infinity, which is not good.
Oh no.
You don't want to ever like divide by 0.
no, man. What the
Yeah.
fuck, man? Get
Math is
your
just self-learning.
ass on.
Okay, so this is equal to 8. All right, cool. So then I can do the exponential form again and just say 2 to the 8 is equal to x plus 5 over 2x. Ooh, okay. That's actually kind of interesting. 2 to the 8th, is that 256? I think it's 256. I guess I could check. 2 to the 8th is 256. Nice.
Good job.
Good job. I recognize what 8-bit means. That soundboard, okay. So this is x plus 5 over 2x. This is kind of a mess to deal with, but it's okay. So we're going to multiply by 2x. That's going to get me 512x is equal to x plus 5. And then I'm going to minus x. So I'm going to get 5. I'm subtracting one of the x's. So I have 511x is equal to 5. So x is equal to 5 over 511. That just seems ugly as anything, dude. What? I don't like that number.
Oh no! Oh no!
Oh, is there lag on Twitch? Let me go check, actually. No, he could be right. It does happen. Yeah, no, we did have a massive lag spike. You're not crazy.
Oh.
You're not crazy. Yeah, that did happen. Alright, 1 second. Let me kill kick. I'm gonna go kill kick. Okay. Yeah, try reloading it. It should be okay now. It does happen for sure. It's because Twitch broadcasts us on 4 different resolutions. It'll do like 1080 horizontal, and then I think 360 horizontal, and then it does whatever, the 1920 vertical, and then also the 640 vertical. Yeah, it's a lot of bandwidth sometimes. Okay. X is 5 over 5. We can go check. And also, right, we had to make sure that was chill with our restrictions, which is just that X has to be greater than 0. So we're good there.
Yeah.
We're a fan of that. Mine defaults, yeah. I think it defaults to, like, whatever. You can set that to automatic, I think. But let's check this, actually. I just want to see if this works. So I'm going to say that 5 divided by 511 is equal to X. And then let's do this. Can I do log base in here? Oh, no, I can't. Oh, it's annoying. Okay, but here's what we can do. We can check that this thing works. I could do the whole thing divide by log 2 if I wanted to, but that just seems annoying. Forgot. Yeah, this calculator isn't as advanced. The newer ones, you can actually set the base within it, which is pretty cool. All right, let's divide this by 2x. And let's see what we get. If we get 256, then I'm fine. We do. Cool. Okay, that one's correct. Yes, exactly. That's the other way to do it. Yeah. Anytime you're not able to put the base into your calculator, you can also say that the log base A of B, this is the same thing as like ln of B over ln of A. Or really log of any base. I just write ln because it's convenient. Rather than writing log and then people are confused.
You're not that guy, pal. Trust me.
no.
You're not that guy.
Okay. Last one. This is fun. Okay. So you're trying to solve for X. Usually when this happens, these bases are numbers that you could make as powers of each other. So for instance, if I had 8 to the 3x plus 2 is equal to 2 to the x plus 1. Let's say we just had this for instance. What you can do is you can rewrite the 8 here as 2 to the 3rd, all being raised to this power. And then power to a power means this would be 2 to the 9x plus 6 is equal to 2 to the x plus 1. And now look at this. They have the same base, so you could literally just say this equals this. That's the usual way we do this. Because then you could just do log base 2 of both sides and whatever. Like, these would destroy and these things come down.
Disqualified.
But they didn't do that for us here, which is annoying. I can't turn 3 into 4. I can turn like 2 into 8, or 8 into 2, sorry. Okay. So, maybe... Fuck, what do I want to do here? Natural log both sides and approximate. I was hoping it would be something nice. I guess it's not going to be something nice, right? I was thinking if there's like some common denominator thing of 3 and 4. Like, does 4 to the exponent of something equal 3 to the exponent? I don't think it does. Okay, yeah, good. No power of 4 can be a power of 3. Yeah, okay. Yeah, so you could
probably try multiply left side by 3 over 3, multiply right side by 4 over 3, and then take the log of both sides, and then in doing so you can break apart the division. You know what I'm saying, right? Because ln of A divided by
you're saying multiply this by 3 over 3, multiply this by 4 over 3?
Yeah.
Well, first of all, I can't do that because that's not
not
by
4
1.
over 4 over 4.
Okay, multiply by 4 over 4. Okay. Yeah, that's okay. And then you're thinking I take the ln of the whole side of ln of both sides?
Log base 12.
Log base 12. Oh, but yeah, this isn't going to work though, dog, because this is 3 to the 1.
Oh, yeah, you're right. You're right.
It's okay. It was a good idea. I was thinking about that as well. I was like, could I get something where they both kind of work? The issue is you can't combine the exponents. You can't combine because you can't combine the bases. Yeah, it's fortunate.
Oh no.
Good attempt though. Yeah. All right, so yeah, the way to solve this, you have to just manually do this by hand. So we're gonna do ln of 4 to the 2x minus 1 is equal to ln of 3 to the x plus 2. And then the cool thing about log rules is the log of a to the b is the same thing as b log a. So this always comes down. So I can just pull this down. So I get 2x minus 1. ln of 4 is equal to x plus 2. ln of 3 And then this is kind of ugly. You gotta run everything through. So fine. So 2 ln of 4 x minus ln of 4 is equal to ln of 3 x plus 2 ln of 3. Okay, so subtract, add. So I get 2 ln of 4 minus the ln of 3 all times x is equal to ln of 4 plus 2 ln of 3. JC brings x isn't going to be rational because prime factors are unique. Okay. Might as well use ln, yeah. Okay, so then we're going to go over here. We're going to get x is equal to ln of 4 plus 2 ln of 3 all over 2 ln of 4 minus the ln of 3, which I feel like I can combine this though, right? This would be the same thing as if I were to put this up, right? This would be the ln of 36 divided by, and then this would be 16 divided by 3. ln of 16 divided by 3. I think that's like kind of the... It is just ugly. She's absolutely hideous, dude. Okay, so we're going to do ln of 36 divided by the ln of 16 over 3. And there you go, 2.14. Seems about right. Just kidding. Don't do it. Okay, cool. Great question there. Pineapple. Would it be too mean to ask a Foucault question, Pendulum? Like with the procession? I mean, you can try to ask it. I don't know if I'll get to it or get through it, but you can turn it into log base 16. Yeah, 3 of 36. Yeah, that would be another way to do that. Yeah, it's interesting. The Foucault pendulum was my main argument I had against the flat earther guy when I did that like whole YouTube thing for him. But he started claiming that the Foucault pendulum had like magnets in it.
Oh no.
I was like, wait, what? Or then he was claiming that the electric fields of the earth like cause it to precess, and I was like, wait, what? Excuse me, what? This is quite funny. He's a cool dude though. He sent me some coffee. Shout out to you, Nathan. You're stuck in frozen ads. Oh no, dude. I thought I turned off ads. We don't get very much money from ads. I don't think. Do we have like mid-roll ads? I hope we don't. Okay. All right, let's go spin. Who's... Yeah, Twitch is messing up, dude. Okay. Let's go spin a winner. Who we got?
Let's go gambling!
Equity! Eclipse, is this the Foucault pendulum? Derive the equation of a Foucault pendulum in the XY plane. Hint use... Oh, man. Alright, we'll see. We'll see if I get to that. Alright. Alright, let's hop out equity here. Did you see, actually, there was something... Yeah, my chat's talking about, like, the cell and stuff. I think they did have a recent news about, like, the coolest, like, photo of the cell. Like, let me think. News... photo of the cell. No, photo of a cell. I thought someone took like a really cool photo of a cell recently, or maybe it was AI, dude. I don't know these days. Can't trust anything.
Brother, this guy stinks.
I think someone did like a really cool photo. Like here, cool photo of a cell. There we go. Here we go. The most detailed image of a human cell to date. When was this published? 5 years ago. No, I saw something like really cool. It was recent. Anyways. Yeah, cells are dope. Was it an elephant cell? Yeah, maybe. Elephant cell? Elephant photo. Alright, I don't know. It must have been some clickbait or something, but I thought it was really cool. And I was like, ooh, look, the mitochondria. It's the powerhouse of the cell. That's all I remember from bio. My favorite, epithelial cells. Oh, cool. Okay. Let H be a polynomial function whose graph has a point of inflection at x equals 4. Okay. Which of the following statements about H must be true? Ooh. Okay. So, inflection means that f double prime at 4 has to be equal to 0. And I think also that f double prime changes signs below and above. And I would say... Alright. Also, f double prime of 4 is equal to negative f double prime of 4. So f triple prime of 4 is not equal to 0? I guess so. I don't think we really have to do the third derivative though, right? Okay. The graph of the rate of change of H has a 0 that will cross the axis at x equals 4. Yeah, this rate of change is just the graph of f prime. I don't think it has to have a 0 there. Because here's what inflection point means. So it's when your concavity is changing. So for instance, this is a type of inflection point right here. This is an inflection point. Because you would be going from like concave up to concave down. That's what they mean by an inflection point. So you don't, the derivative definitely doesn't need to be 0. Take the third derivative, be a jerk. Okay. The graph of H has a relative extremum. That's also like not true. Okay. The graph of H is tangent to the x-axis. Also not true. Dude, it has to be just B, just by process of elimination. Oh, sorry. Yeah, sorry. Not E. Sorry, this is what I meant to say. I meant to say... can we say like 4 minus epsilon? Can we say that? Is that cool? Okay, the graph of the rate of change has a relative extremum at x equal to 4. I will agree with that. Yeah. Because here, right? This would be, f prime would be 0. F prime would be positive, right? And then it becomes like less positive. I see. Yeah. And that's another way to think about, like, so, okay, at extremes, usually like the first derivative, did they say it was a maximum? They just said it was a relative extreme. Okay. The first derivative is equal to 0. And then we would say that first derivative is changing signs. Okay. So usually on a regular graph of f of x versus x, I'll put like 2 examples of this, right? These would be extremums, right? So here, notice that f prime of x would be equal to 0. And then the f prime is changing from positive to negative. And then here, same thing. Dr. Gold, I don't know calc. Well, this is very much a calculus question. What? What? I don't think you can deal with inflection points without knowing calculus. Can you?
feel like there's a way. I remember doing it. I don't know.
Is there?
But
Dude,
I
what the
feel like
fuck?
there's a way.
There's
I
a way
don't
to do
know.
this without calculus?
I remember hearing inflection points, and I can't remember if it was algebra 2 or pre-calc, but
That just seems really
I
dumb.
think it's possible.
It's like telling someone to, like, I don't know, go make an omelet without eggs. It's like, yeah, you can. But, like, why? You learned about them in pre-calc? Okay. I'm trying to think how to explain it to you without calculus, though. Because if the rate of change, I mean, I guess the only other way to do it is to memorize, like, what the inflection points can look like, right? This is an example of an inflection point. And then, what's the other one? You could have, I guess you could have this. Yeah, you could have this. Right.
Yeah, I forget how you're supposed to do it, but it's possible. I tried looking it up, and you know, despite how far we've gone with AI, it said to find inflection points without using calculus or using a graphing calculator, graph the function and use a graphing calculator is what it told me. So
Yeah, so they're just telling you to graph, which I don't know. This it's fucking whack. But sure, I mean, this is another example of an inflection point, right? Because you're going from happy face concavity to sad face concavity.
Emotional, damn it!
And then this is another extremum, right? Because extremum can also mean like an extreme minimum, I guess, right? Second derivative doesn't necessarily have to be 0. It doesn't? I think it does. I mean, unless it's a jump. Okay. An inflection point is where the graph changes concavity. Mathematically, it's where f double prime changes usually where it equals 0. Can it not equal 0?
I think when I want to say when it's undefined.
Yeah, you could have a jump discontinuity. Okay, here. Let's just look at some examples. Right? This makes sense to me. Because you go from like concave up to concave down. That's a switch. Same thing here. Concave down to concave up. But I don't think that fits into what we say that the graph of the rate of change has an extremum. Oh, I guess so. Because rate of change is going from positive to 0 to positive. Oh, I guess it's a saddle point. Right? Yeah, I know the rate of change is just f prime, so let's look at what that would be, right? If you were to do this as like a graph, you'd have a very, very positive rate of change, right? So that's like up here. And then that would slowly go to 0. Right? And then the slope would start increasing again. Right? So, and is this called an extremum? I guess it is, right? It's a minimum. Okay. Is the rate of change at the position equal to 0? No. So here, for example, the rate of the change is really, really big. Here, the rate of change is equal to 0. Correct. So here, if this was a graph of f prime of x, which is a graph of the rate of change, then yes. The rate of change can equal 0. But more importantly, it's a minimum. It's a minimum rate of change. So it's an extreme. So the rate of change at the point of inflection can be 0. In this case, it's not. This would be, if we were to graph this, so this would be like negative to 0, so it would look like something like that. And then it would go to being positive. Well, here, let me line this up correctly. Let me line up all the points. So for instance, here the slope would be 0, if this was a graph of f prime of x. Here the slope would be maximal positive. Here the slope would be 0. And then whatever, it would be negative. Oh. So this is what your graph of f prime of x would look like. So this, yes, would be a maximum rate of change. For the second graph, the rate of change is 0, correct, yes. And then here, this would be a minimum rate of change. This would be another example of kind of like a minimum rate of change, but it's a little bit different. So again, let me get some points. This is important, this is important, this is important. So here, your slope is very negative. Here, your slope is 0. Here, your slope is 0. And then your slope is very positive. And then here, your slope is very positive. So in this case, the rate of change is not 0, but it is still a minimum. Okay, good. How do you know the rate of change at the inflection point for the first one is a maximum? Okay, cool. Good question. Because it's going from having a slope of 0 to having another slope of 0. And I don't know, this becomes like slightly more positive, then it becomes the most positive, and then it becomes like slightly like this is also what's called, I think, like the intermediate value theorem. If you know you have to go from 0 to 0, there has to be a point at which you hit the maximum. We agree that because you're always going up, the slope is always positive, right? So that's why, like, looking at this graph, for instance, from here to here, the slope has to go from being 0 to being 0, right? This is 0 slope. This is 0 slope. So it always had to stay positive. So there had to be some point at which it was the most. And then what you learn is, this is where the calculus comes in. The inflection point being 0 represents where the slope of your slope, so the slope of this, right, going from positive to negative, is occurring. And that's where this, so we can say like f double prime of x is equal to 0. And that's the slope of f prime of x. So the slope of this graph, which is then another graph, is where that kind of comes in. There are 3 types of people. I do the second one, sensation, actually. I'm a second enjoyer. The world is fixing itself slowly. There's an option for a $4 6-inch at Subway. Wow. I mean, yes, praise. Don't they have like a weekly special all the time at Subway? Like this one's on sale or something?
Yeah, they have.
It's like the sub of the week.
6-inch deli faves right
Slop
now,
of the
which
week.
are the $4 ones. But then there's also the $4.99 sub of the day and the $6.99 meal of the day.
If you just put enough vegetables on it, it's okay. I just tell them just like, yeah, load up on, because they can't say no to like extra cucumbers. I'm just like, yeah, put a fucking salad on there. Okay. Does this make sense, Equity? It's kind of funny you guys learn about point of inflection without knowing calculus. Kind of weird. It's like that. I mean, this is kind of psychotic. Okay, cool. I'm assuming that makes sense to you, Equity. Good job. Great question. Love it. Good job, Equita. Again, all the questions we do always get put into our Discord. So you'll see here when we mark it as done, Equity's question will show up right here. And then what we like to do is we'll drop in the screenshot for what we did during their question so they can go back and see it. And then also there's a nice little timestamp for where they can rewatch it. So for those of you that are watching, this is a great reason to join our Discord because all the questions we do here end up here and you guys can talk about them and get help and all sorts of fun stuff. If you want to know how to join our Discord, there's that website, actualofficehours.com. Just click on it and then there's a little link here for join our Discord. Go do it. Let me see. There are 3 types of people. Yeah, so I do the second. The third is diabolical. Absolutely. Like, this is not coding. This is pain. I am not a fan of putting the bracket in the line. They should have done the 4th option where like some people will do this all in one line. I've seen that before. I am learning every day. Yes, we love learning. Lifelong learning is the goal. Okay. Let's go see who's the next question we're going to go through. Let's go pick a winner.
Let's go gambling!
It's testicles. So we've had the OG breasticles, and then we have the impersonators of testicles and boobicles. You didn't.
They're not as good. They're just they don't
boobsicles isn't even
off
spelled
the
right.
tongue the same way.
Yeah, testicles isn't even clever.
Yeah, they just. It just doesn't. It's not as fluid. You know?
Oh, dang
It's not
it!
as natural.
Not as natural. I don't know if breasticles are natural. I don't know if that's what like God intended, but
I mean, not the actual.
not the actual
like
concept.
the people, yeah, but the name flows off the tongue naturally.
All right. If P of n is the nth prime number with P of 1 being 2. Okay, sure. What is P of P of P of 4 plus 1? This looks like a problem to solve by coding. Don't I just need to know like all the prime numbers? Is that all I need? I just need to list all the prime numbers?
I was able to get like, I think it was at like P of like 19 is the final P or something
here, I'm just
like
gonna
that.
tell chat.
And then I was just like,
Give me a
too
list
lazy to-
of the first 100 prime numbers. Just go do it for me, chat. There we go. Love that. And it was can you put these in a spreadsheet such that the first prime number is in row 1?
I think you only need like 20 or 25.
Yeah. Stop, Femvox. No.
Actually, I think Femvox.
Femvox, are you spoiling?
Oh,
Is
no.
Femvox spoiling the answer here? Okay. I'm gonna pretend I didn't see it. This would be great if this actually works out. Also, why can't chat just like put this in a spreadsheet for me? Like, come on, dude. Do I gotta go do this? Come on, Clanker. I have to like literally do this myself.
You could just like start counting.
I didn't want to count. I don't want to count. I don't want to count that much.
Like
It's too much.
4.
Oh, I can't even like put these in a dude. Okay, dude, this is hilarious that like chat's just taking this long. Fine, fuck it. All right. Jeff.
My name is Jeff.
Okay, here we go. Okay, so P of 4. P of 4 is the fourth prime number, so that's 1, 2, 3, 4. So that's equal to 7. Great. But then I need P of 7 plus 1. That's equal to P of 8. Okay. So 1, 2, 3, 4, 5, 6, 7, 8. So that's equal to 19. And then I need the P of 19, right? 19th number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16,
Yeah, I can
17, 18, 19. It's equal to 6, 7. Oh no. Oh no.
Oh no!
God!
Oh no!
No! God, please, no!
I thought this. I was like, as soon as I looked at it and I started doing it, I got the P of 19. And I was like, I'm not counting up that high, but I was like,
It wasn't
this
that bad.
seems like really easy for what would be like a.
People just keep trolling me with these 6, 7 questions. Yeah. Because I thought it was gonna be like yesterday's questions, which were being like super ugly. What was it? It was something where it was like the nth of something.
Yeah. Or
Wait, who is this? This was
like-
testicles.
Yeah.
Wait, let me find. Whose was it? I probably kept it in here. Was it from yesterday? Yeah, this one. This one was a mess. I'd love to do a 67 joke with a complex math question in a few years. Yeah. It was good. It was well played. But now I'm going to be suspicious that anything that gets submitted by someone representing our infamous breasticles is going to be a 6-7 joke. All right, let's see.
Maybe I'm like, the master of puppets controlling them all, and they're all like.
Wow. It's like people think
6-7 jokes.
I control Actual Education's dad. I'm like, no, I don't control that account. Okay. Jeff.
My name is Jeff.
Okay, let's go spin another winner. Who is it gonna be?
Let's go gambling!
Eclipse. What'd you say, baby code? Why did I get mad at you? Here, you can say bad words. Sorry. Okay, derive the equation for the position of a Foucault pendulum in the xy plane. Use n of t is equal to x plus iy to solve the coupled equations. Let's maybe just explain like how a Foucault pendulum works. It's actually quite cool. It involves a lot of like spherical geometry, Eclipse, doesn't it? Let me get an image of it. Foucault pendulum. So you guys might have seen these in like, they have them in museums and stuff. There you go. This is kind of it. Yeah, something like this. This is called precession. They precess back and forth. And the reason for this is that the Earth is a sphere and it rotates. Why can't I open this image? Sorry, what? So, if, for instance, you had a pendulum that was spinning back and forth, like this, back and forth, back and forth, back and forth, and then let's say that the ground underneath you is rotating. The simplest example of this is if you were at the North Pole doing this, right, and the Earth is rotating around. Then what would happen at a later point in time is you would no longer be spinning relative to the ground. in the same axis, you'd be spinning in a new axis. Because like the ground is like rotating underneath you. And then it so happens that the amount of rate of precession it takes and the amount of precession that happens is dependent on what your is it latitude? I think it's latitude, right? I always forget which one's latitude or longitude. One sec. Yes, it depends on your latitude. Okay, cool, great. I'm not completely dumb. Yes, and I think it depends on the sign of your latitude, right? I think it's like sign of phi or whatever. So if you, for instance, were on the equator, you would actually not see this thing precess at all, because the ground underneath you would be moving exactly, I guess, like perpendicular to what your movement is. Yeah. So that's why it works. The equation for it, let me see. I don't think I can do it like by hand, but it has to do with like a rotating reference frame. Dun, 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 dun. Interesting. Yeah, you need the non-inertial reference frame stuff. Yeah. Right, okay. Equation of motion for a pendulum without any sort of Coriolis force is this. The LDT is equal to ml squared v double prime, where L is the angular momentum relative to the oscillation axis. N is equal to negative mgl sine theta is the force moment. And this is, oh cool, this is where you get square root of g over L. Why is that again, actually? Let me think here. Oh, I think, here, I'm not going to go through and, like, derive the whole Foucault pendulum, because, like, yeah.
Oh, no.
I mean, I'll look at it, but let me at least, like, see if I remember how to derive the equation just for a regular pendulum. And it is a differential equations thing. Yeah, there's Coriolis, and then there's also centrifugal. It gets really messy. Do you actually have to do that in your class?
This guy stinks!
That's fucking awful. Okay. Because this thing is... You do? Wow, that's ugly. I think I remember you saying you're taking physics at MIT or something, though. That's probably why. They just hate themselves over there. Or whatever. They say it like builds character or something. So it has to do like this. So yeah, L is equal to I omega, I think is what it is, right? Which is also equal to R cross P. And then there's something with like the torques as well, because there's a restoring force. So when a pendulum goes back and forth, right? It's because there's a force of gravity that's pulling it down. And then this is like I don't remember how this works. Because this is like theta. And then let's call this distance L. let me think some other things real quick. Torque is equal to R cross F, which is also equal to I alpha. And then I for a point mass is going to be ml squared. Oh, wait. And then I think... yeah, dPdt is equal to F, right? Because F equals MA. Wait, yes. P equals MV. Okay. So, if L equals R cross P, then dL dt is equal to... you assume R is not changing, right? That's R cross dP dt. So, oh, and that's where the R cross F comes from. Oh, very cool, actually. Oh, so dL dt is equal to torque. Okay. I love how, like, physics is all self-consistent eventually. And then, okay. Yes, and this torque is equal to I times alpha, where alpha is the second derivative of the angular displacement, right? So this is equal to ml squared. And then alpha is going to be theta double dot, right? Oh, okay, cool. So I think you get this, right? You get dl dt is equal to ml squared theta double dot. Is that what they had? They said dl dt is equal to ml squared. Oh, yeah, they say v double dot, but I think v double dot is n double dot. Oh, we didn't have all... oh, that was a different person. It was an in-class example. We didn't get all the way through, so I'm still a little confused. I didn't have to do this for homework or anything. Yeah, it's probably one of those, like, fun, like, derivations they have you go do. It's an upper division mechanics class for sure. For sure. And then, wait, where does the MGL sine theta come from? Yeah, and then they do, like, the small approximation. So they say... they're kind of actually messing up their symbols here. Okay. Okay. Anyways, alright. So let's assume this is true. M R double dot is negative K effective R. Now we add the Coriolis force since the mass cannot exit the plane. Equations valid on the... oh, man. This theta is different than... oh, so this was an oscillation angle. Oh, okay. Okay, so I was right here, actually. Interesting. They assume that theta... because... where's the sine coming from, though? If you have a pendulum at 40 north, 0 east, and it starts north-south motion, you can calculate those vectors relative to the Earth. Since no force is applied, the pendulum will always be swinging in the original north direction, even as the Earth rotates. What's so special about the 40 north? Oh, you just made that up? Jeff.
My name is Jeff.
Oh, no.
I was like, where the fuck's that 40 coming from? Oh, man. Where do they get the mg over L? Sorry, where does that come from?
Trying to remember.
Yeah, what? How do we get
I've
square root
seen
g over
that
L
in
from
a-
this?
I've seen that in like one of the pendulum equations like a lot.
Yeah. I know it's square root of g over L. I know what it should be with the omega, but I'm confused how they get to that. Oh, okay, we assume sine of the angle is basically equal. Where the fuck did sine come from?
I think we have to consider sine when it's not a small angle. Normally.
No, wait. Oh, wait. Okay, wait. R cross F, right? This is L times F perp is equal to ML squared theta double dot. Okay, this is where this comes from. Okay, because F is mg, right? Yep. Mg points up, down. So I need the perpendicular component of L, and that's going to be L sine theta. Aha. Okay, I think I see where this comes from. Right. So F perp is equal to mg sine theta. Got you. Okay, so then you get this. You get mgl sine theta is equal to ml squared theta double dot. You approximate this as theta. Cancel that. Cancel one of those. Okay. And then you get the wave equation. Yeah, so you get g over L theta is equal to theta double dot. And then this is a common solution where omega is equal to square root of g over L.
It's actually not the wave equation. That's Helmholtz.
Whatever, not the wave equation, the simple harmonic motion equation thing, you know?
Yeah.
SHO. Yeah. Okay, I can derive basic pendulums. That's great. Love that. I don't know how you start applying all this Eclipse, unfortunately. This starts getting fucking crazy. Like, what? Oh, man. Like, where'd they get from R? Instead of... Okay, so they say instead of theta, we can change our variable from theta to R is equal to L theta. Okay. Which measures the distance from the axis. Okay. In the small angle limit. So they're also saying this. That, like, this distance right here is equal to L theta. And they're going to say that's equal to R. I see, because it's going to precess around that axis. There's a couple axes, right? Yeah. So this is like, this angle right here, I guess, is like phi. And then they're describing this distance, whatever, yeah, as okay, if this is theta. Yeah, there's a bunch of cross products and ugly stuff. I'm starting to see it, though. It's cool. Yeah, this is theta, and then this is going to be L theta is like this distance from this. And then you need that distance times phi to be the precession angle.
Yeah, I think they're assuming that, like, in the small angle, it's just rotating around a flat circle. It's not actually going up or.
Oh, I see. Yeah.
So
the pendulum is sufficiently long. Yeah, got you. That's actually a good point. Oh, okay. So I didn't even think about that, because I thought when you're making a Foucault pendulum, you need it to be pretty heavy, right? Because you need enough momentum to fight off air resistance and any sort of friction, right?
Mm-hmm.
But I didn't even think about, like, why it needs to be long. It needs to be long such that the angle of displacement is small. That's so cool. I didn't even think about that. Yeah, because you want a long period, right? You need a long period in order to be able to, I don't know, detect the differences maybe between things or something. Or also just because any sort of losses due to air resistance or mainly friction probably increase as your frequency increases. So you want your period to be up to decrease the amount of friction that's happening. I think the air resistance is regardless. But then, okay, that makes sense why Foucault pendulums are long. Because you need a small angle. Okay. And then you have to do this. The Coriolis force. Why is it minus 2m? How do you check channel points, Zepstar? You should see them. You should see them in your... It should be down there in Twitch. Should say. Okay. And then there's the slow precession approximation. So look, so then they assume that the angle of precession is slow. So it's another like, oh, well, whatever. We're just going to say sine of theta equals theta. And this is the cool thing I know. The period of the precession is inversely proportional to the latitude. So, right. Yeah. Okay. Yeah. I don't know if I can run through this and explain all this, but this is cool, Eclipse. I appreciate you at least submitting it. If someone wants to try to explain it, they can on my Discord, but otherwise, this is also fun for me to relearn, I would say, like, intro physics to remember what the omega for pendulum is. And for me to realize that Foucault pendulums need to be long in order for theta to be small. That's also really cool. I didn't know that. I learn something every day. I appreciate you submitting this. Nice. I'm sorry I couldn't actually like solve it and understand it, but there was knowledge gained from it. Yeah. If you want, I'm sure someone does a derivation of this on YouTube. This is the beauty of the internet. You guys have everything, right? Or even I could have probably asked ChatGPT to actually just go through and derive it. It's a well-known derivation. And then you can ask ChatGPT like during the steps, be like, yo, where the hell did you get that from? I guess the visualization would be tricky though, right? So maybe if I don't know, if you go to YouTube and like mathematically derive Foucault pendulum. I'm sure someone's done it. Yeah, here we go. Here's something from 10 years ago. 34 minutes. I wonder if this person has a very heavy accent. Yep. Might be coming in. Let's see. I'm just curious who this is.
They definitely do.
The first thing we're gonna need.
Oh, this person's actually chill.
I can't hear it, but I can see it through the screen. I can see by the big red like cursor, and then physics menu with no icon, and the whiteboard, and I can just tell.
I can see color.
I know it.
Wow, there's quite a lot of steps on this. Okay. Yeah, so maybe run through this. Someone's done it. I'm not going to reinvent the wheel. They are very cool, though. I implore...
Hi, this is Jason again.
Oh, hi, Jason. Oh, okay. So maybe this guy also, like, derives it down. Right? Here's, like, kind of the small displacement. He talks about this. Wow, dude. These people make 30-minute videos on this. This is crazy. Who's this Jason Kendall guy? He's an astronomer. He taught astronomy at William Patterson University. He likes model rockets. And he just does like really cool videos and stuff. Yay, for education. Sine x is equal to x and cosine of x equals to 1 if you try hard enough. Yes, I believe in that. Okay. Cool. Anyways, yeah, so go check out those videos. 30 minutes. All right, let's go spin the wheel again and see who's going to get it.
Let's go gambling!
Equity!
Me! Oh, never mind.
What's up, Nick?
What's up?
How's life, dude? Making more pizzas? Make more pizzas, dude?
About to go get some more, yeah.
I love this, dude. I love that you're experiencing being an adult. It's such a rare thing, actually, these days. Like, unfortunately, most of Gen Z doesn't fucking leave the house.
But now I'm running into a conundrum.
Oh, are you learning, like, how to live with other people and all the fun that comes with that?
Fuck that. I'm eating it.
This guy stinks!
I'm going to get my own place.
Oh, okay. Well, that was fast. I lived with roommates for probably, like, 10 years, dude, before I finally got my own place.
Fuck them. I mean,
Fuck them.
Oh, no.
Okay.
That's what you
I
gotta
think-
do so you can end up like Sheldon Cooper.
Oh my god, no,
Maybe.
dude. Living with roommates, yes, is tough, but it's so worth it because it forces you to really learn how to be friends and amicable with people that you usually would not be. I think it's a very important skill. I mean, I'm most happy that you're not living with your parents. So if you need to get your own spot, cool. I have no clue what the environment is nowadays trying to have random roommates. My first roommates I found on Craigslist, which I don't think anyone should do that anymore. But back in my day, it was okay.
Back in my day. Yeah, but now I'm running into a conundrum. It's either I stay and pay for ridiculous prices for housing, or I leave and go to college.
Are you leaving to go to college? Wait, you just got your job, dude. Wait. Don't quit your job yet. Do your job for at least like a year.
But then it's another year waiting to go to college.
Yeah. I don't know. I would since you already studied a lot to get this job, Nick, and getting a job even these days is not really like a guaranteed thing or an easy thing. I would stay at your job at least for a year, just so you can put on your resume that you spent a year there, and it looks good for other people. Yeah, if you start a job and then you like leave it 3 months later, it just starts to look questionable for things. And I used to be a big supporter of go to college no matter what, but nowadays I'm seriously reconsidering that because college isn't for everyone. I used to think college was. I used to think that like everyone should go to college. Now I have doubts because I see a lot of people with college degrees that can't get jobs because I don't know, the whole dream was kind of a lie. So, not knocking it, you should go to college if you want to pursue like higher things, but it's no longer a guaranteed income improver thing. So,
because I'm thinking of going to like engineering and then maybe like Air Force to do like aerospace or something.
Yeah, so if you want to do that, first of all, engineering is tough. I mean, you were complaining in my Discord earlier. You didn't know what a factorial was.
You're not that guy, pal.
So,
Trust me. You're not that guy.
I'm just worried if you're gonna like quit your job now to go straight into an engineering program, because it's gonna be tough. Engineering is a very difficult major to just like throw yourself into.
I mean, I like math, so
I'm glad. I'm not discouraging that. I'm glad you like math. It's great. What I would suggest, rather than like dropping your job and then like saying I'm gonna go be an engineer, try taking a calculus course at a community college nearby and see if you can pass it. That would be like that would be my suggestion. And like you'll find out pretty quickly after the first couple weeks of your calculus class whether you actually want to be an engineer or whether that was just kind of a nice idea that is going to end up being really difficult.
Damn.
Yeah.
Okay.
I'm just saying be a little cautious, you know? Yeah. And also, I mean, you're getting paid, you have a job, these are great things that you don't want to take for granted right now. You have benefits probably too. Yeah, you got a pension, you got dude, I didn't have fucking healthcare for years, dude. Like what? Like these are very good things to have. Don't drop them until you at least know that the next thing will pan out more.
Well, if I leave, I have a year to come back.
Oh, okay. Well, you can still do both. That's what I'm saying. I'm saying you can do both. And that's what the community college option is. And like whatever night school option is. This is great. And also you don't have to take a full 4 classes a quarter. You can literally just sign up and take 1 class. And that class I would take for you to like see if you actually want to do engineering is go take calculus. And see how that goes. And if that's good, I would then also maybe take an intro physics class. See how that goes. And if these are both things that like you're willing to put in the work and it's okay and you're vibing, then you can think about, and also doing these things aren't a waste. These are credits that will transfer into whatever college you go to do that program. These are like what we call like the basic prereqs you kind of need. Then you can start pursuing the higher level stuff.
Gotcha.
Yeah.
Okay.
Yeah, but all good.
Thank you.
You're very welcome, dude. Happy to give advice. Like Lucky Cat says, Dr. Gold, when should people move out of their parents' house? Yeah, now.
if not tonight or tomorrow,
it's
yesterday.
It is such a valuable part of your upbringing to have to learn how to live on your own, to figure out, oh, I have to do my own laundry, I have to feed myself, I have to keep my place clean, and no parent is going to yell at me to do these things. This is why I would advocate a lot for kids to go to college, is because more important than the education is like the social education and like the social development of having to be an independent human. I know financially it doesn't work out for everyone, and that's okay. You know, don't go into massive amounts of debt for like the social experience. But if it's possible, whatever, scholarships, or you're fortunate enough to have a university close by that's not very expensive, or you have parents that are willing to pay, I think you should push for it to go do it, because it'll teach you a ton about just living that unfortunately you can't really. There's so many like little ancillary skills you learn when you have to get out of the house, such as also like hosting friends. Like this is another thing that's like dying in today's culture, is nobody knows how to host people because they're at their parents' place, and you can't really invite your friends over to your parents' place. It's fucking lame, you know. So these types of things are important, and I think the requirement there is you have to leave. You gotta get out of the nest. Get out of the nest. I'm glad Nick did it. There's no like wrong time. You just have to do it at some point, sooner than later, and then whatever like financially makes sense for you. That's what I would say. Yeah. The houses are too much and the rent is too much. I know. It's unfortunate. College is not the only way to be successful. No, there are tons of people that didn't go to college and are successful. But that being said, don't use that as an excuse for I'm not going to go to college because I want to be successful. Like, no. In general, going to college correlates incredibly well with being successful and making higher income. 100%. I mean, that's a very strong correlation. But if college isn't for you because, let's say, you're more inclined towards trade skills, or I don't know, even some other sort of thing, you don't have to go to college. There are other ways to be successful. If you have no clue what you want to do, then in general going to college is a good idea, because you'll probably figure it out. Yeah, the college of OnlyFans? Oh no. Damn it, that is the other problem, dude. These fucking 18-year-old kids who they don't even try to make a living legitimately. They just IPO with some OnlyFans and like, oh yeah, whatever, this is easy. Don't do that, please. You have so much potential. But yeah, if houses are expensive and rent is too much, go find roommates. My first apartment in Hollywood was 5 of us. We had 5 people in a 2-bedroom apartment in Hollywood. It was $500 a month. You can do it. Yeah. It was a madhouse.
$500 a month?
It was $500 a month, but it was 5 of us. So it was like 3 people in one bedroom and like 2 people in another. So.
Damn, you guys are gangbanging and everything?
Yeah, not really. But
That's dope.
Oh no.
Damn, that's crazy.
Yeah, you have to make sacrifices. And I think that's another important part about growing up, is learning that if you want things in life, you have to give up short-term things. Or like you have to give up comfort. You have to give up safety and security. You have to like take risks. So yeah, I made it work. I wanted to live in Los Angeles. I only had a set amount of money, so I decided to be able to live with 5 other people.
Were you all working?
Yeah. Well, I was in grad school. One of my friends was a waiter. My other friend was, I think, in healthcare. My other friend was a fitness personal trainer, and then our other roommate, I don't know. I think he like sold drugs or something. But people just do stuff. But these are all like the spread of people you meet in life, and you'll only get that from having roommates. I say roommates are fun because it forces you to be friends with people that you wouldn't normally be friends with. And I think that's an important skill to have in life, because everyone in the world is not automatically someone you would naturally gravitate towards to be your friend, but you're going to be put in situations where you have to act friendly to each other, and you learn that through being roommates with, again, sometimes randos on Craigslist, or in college they usually assign you to a dorm is what they'll do. They'll assign you roommates. You get to fill out like a questionnaire, like what type of stuff do you like, and they try to match you with things. But I think it's very important to learn how to coexist with people that aren't necessarily like your top pick for people. Yeah. Dead chickens? What are you guys saying? Dead chickens. Okay. All right, enough of my ranting and yapping, but I hope that makes some sense to you guys.
Philosophy with a goal.
All right, thanks, Zevstar. Yeah, all right. Let me help this question for Equity.
All right, thank you.
You're welcome, dude. A nature preserve has 1,400 feet of fencing to enclose a rectangular flamingo habitat. Oh, cool. However, one side of the habitat lies along a river and requires no fencing. Express the area as a habitat as a function of X. Okay, cool. So this is a systems of equations and then an optimization problem, I think is what it is. Jay says, what are my thoughts on CS? CS is good. As a major, it's no longer a guaranteed, payday, but it's still a valuable skill to have. And Calc 1 and 2 are not that bad. Calc 3 can sometimes suck. Okay, so express the area as a function of X. Okay, great. Okay, so area is equal to length times width, right? And so the length times width of this is equal to X times Y. But they want it only as a function of X. So then the next thing you have to do is use this bit of information that says you only have 1,400 feet of fencing. Oh, sorry. Let me show you guys a question. My bad. Yeah. Sorry, I was fucking up. It was showing on TikTok. I wasn't showing it on Twitch. My bad. Okay, sorry, guys. All right, sorry. This is the question. This is Y. This is X. The area is going to be X times Y. That's probably what you're trying to maximize or something. But they want area as a function of X. So I need to use this bit of information that says that you only have so many feet of fencing. The fencing is only going to be this, and this. So that's going to be Y plus X has to be equal to 1,400. TikTokers get the special treatment. Well, they actually get the short end of the stick because my chat is not showing in TikTok right now. I'll go fix that later. I don't know. TikTok's fucking awful sometimes with that. They also always get shown what's on my screen, so they don't get any of the special stuff because I have to run it through a separate client. Okay, so this tells me, cool, that 2y is equal to 1,400 minus x. So then y is equal to 1,400 minus x all over 2. So then I can plug that in. And so I would get this is equal to x, 1,400 minus x all over 2. And that's equal to the area. So there you go. That's area as a function of x. That would correspond to choice C. The reason why they do this is you're eventually going to want to like maximize and you want to figure out like what dimensions would maximize the area for this and which ones would give you the least area, like in terms of length and width. If you were to expand this out, right, you would get A is equal to 700x, and then this would be minus x squared over 2. Okay? This is a cool looking function, right? Let's say you have y is equal to negative x squared over 2 plus 700x. You could rewrite this out as a parabola, and what you would see is that it would look something like this. So the negative x squared, when you have like y is equal to negative x squared plus blah 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 blah, that's gonna be like a sad face parabola. And because of that, you know that there's always going to be a maximum, which is also equal to the vertex. I make algebraic manipulation look smooth. Thanks, man. So, yeah, there you go. Fem already figured it out. Fem said the max is at 467. Yeah, okay. So, what you end up doing, again, if you haven't taken calculus and you're just in pre-calc, you would solve, you would make this look like it's in vertex form. And the way to do that is to, like, complete the square. So this, you end up doing like completing the square. And that'll get you y is equal to a, and then that's going to be x minus h squared plus k. And then this right here is your dimension of x for maximum area. Speaking of functions, can you show how to find the vertex form? Yeah, no, I can do that. Here, let's just do this one. Here, and let's verify that Fembox is correct. So let me just do that. Okay. Let me do completing the square here. So y is equal to negative x over 2 squared plus 700x. First thing you need to do is you always need to make sure that there's nothing in front of this x squared. So I got to factor anything else that's out there. So I'm going to factor out a negative 1/2. So I'm going to say, okay, cool. Negative 1/2. And this is going to be x squared. And then this is going to be minus 1400x. Like that. I think that's correct, right? That's what we got. Do that right? Yeah. Yeah, cool. Okay. Next step is you take whatever the middle number is here. You divide it by 2 and you square it. So I'm going to do 1400 divided by 2. So that's 700. Then I'm going to square it. And then I'm going to add 700 squared. And I'm going to subtract 700 squared. Okay. So then this whole part here is going to become x minus 700 squared. You rounded for the 6-7 to make Jeff proud.
My name is Jeff.
Hell no, man. What the fuck, man? Get your
Okay.
ass on.
Okay, so then this is negative 1/2. So this whole thing always becomes what's called a perfect square trinomial, which means you can write it as whatever this is plus or minus this thing, and then all of that squared is this. But then you also have to deal with this part, which this would be then minus 1/2 times, but then this is a plus. The minus is a plus, so this would be plus 1/2 times 700 squared. Okay, so that tells you what the now you know what the vertex is, right? Vertex is at x is equal to 700. You said 467 Fembox? Did I do something wrong? I think I did this right? Yeah, no, I think this is right. So vertex is at 700, and sorry, this is an area. Sorry, this is area though, right? Yeah. I wash my hand of this flim flam. Okay. So vertex is 700, so that's the dimensions for x. And then you could find from this what y would need to be, right? Because 2y plus x is equal to 400. And then 2y plus x is equal to 1400. So if this is now 700, you get 2y is equal to 700, so y is equal to 350. And then, where's this 467 coming from? You guys are getting? I think the area's gonna be much bigger than that. Oh, you're using the shortcut.
About it, you can just approximate anything to 467 if you're general enough with what's close.
God damn it. Okay. Okay. So vertex at 700, comma, and then y, which is a at this point, would be equal to 1/2 times 700 squared. So you can pull your calculator out and just get that. So 700 squared divided by 2. So I get 245. Did you do like another square root, Fem, there? Oh, okay. Or I guess if you square it, you get... Oh, you did 4 sides instead of 3.
Oh no.
Emotional, damn it!
Oh, Jay, that's too funny. Your teacher banned you from using the B over 2A formula to find the vertex. I mean, it works as well, technically. But
To be fair, 467 and 215 aren't that different when you consider, like, how big the universe is and then it's infinitely expanding. It's not really that wrong of an answer.
this is getting so philosophical, dog. Okay.
That's
So,
what you got to do when you get the wrong answer. You just got to make
Yeah.
it, like,
that
philosophical.
it was like that time ChatGPT, right? We were trying to do the electrostatics question, and it was like, oh, well, yeah, E is just this. And you're like, wait, why? It's like, just because it is, man. It's cool. All right. Cool. All right, there you go. Good job, Equity. Hope that helps out.
That's dope.
Oh, I gotta give you a coin. Okay. Pineapple. I didn't give you bond coins either. Pineapple, dude. I'm messing up everywhere. And I didn't give it a breastplate either. Wow. There we go. Okay.
Well, yeah, I mean, that's fair. Yeah, that you didn't give it. Because, like, I gave an easy question, so, like, normally...
It doesn't deserve it.
You know, well, no, I mean, like, normally, you know, your body's, like, natural clock would be like, okay, I'm going to give him a bond coin at this point.
Oh no.
Not, you know, 5 to 10 into the stream.
What did Jay give me this? What? Calculate average acceleration. Where's the cage wall? Let me just do this one for you, Jay, real quick, just because you're on. I'll put some more time on the clock because I did spend like 5 minutes yelling about like why you guys should leave the house. Yeah, let me do Jay's real quick, just because you've been waiting on TikTok. And TikTok, I know, has the least attention span of all of my platforms. So I want to acknowledge your question before you leave. So let's do this one real quick. A batter in a batting practice cage, the ball undergoes an average acceleration of this. I don't know what the W part is. In that many seconds before it hits the cage wall, calculate the velocity of the baseball when it hits the wall. Oh, west. Oh, okay. Oh, that's fine. Before it hits the cage wall. Okay. So, okay, I have acceleration. That's cool. And I have time. And I'm trying to find V, right? And I in this case, I'm trying to find VF. I think we're going to assume that V naught is equal to 0. Right? And so then how you always do these questions, Jay, is you look at your Kinemax equations you have, and you just see like which equation has the things I want and what I'm looking for. I'm too lazy to write them all out, so I'm just going to pull them out right now. So I need one of the equations that has A, T, VF, and V naught in it, right? That's gonna be this one. See how this one needed like change in position? I don't want to do any of these because I don't have the change in position. Yeah, I definitely want to do this one. No, fuck that. So yeah, you want to use this equation. So this is V final. So I'll say, cool. Well, V final is equal to 0. I'm gonna assume average acceleration. Yeah. I think we can use the average though, no? Or
Could do a collision.
yeah, but then I
We don't know if it's being thrown or if it's stationary when we hit it.
I assume the reason why they're saying average acceleration is because there's a force being imparted on the ball. I don't think it's that serious. No, velocity is not constant. Can't be. If you have acceleration, velocity is 100% not constant. I think it's literally just this. I think it's just plus A times T, and you can say average. Am I crazy? I don't think I'm crazy.
I feel
impulse
like
is
you
what
can, but
he's thinking about. Impulse. You could do impulse.
yeah, I feel like the math part of me is like, this is not rigorous. I don't want that.
Well, yeah, the issue is, so they say an average acceleration. So that means, because I guess the acceleration is changing from when the ball hits the bat and then when the ball rebounds off the bat and goes the other way. That's one way to do it. So in that case, you have to say like F delta T is equal to M delta V. But, man, I don't know. But then I need the time of the collision. I don't have that. Oh, okay, interesting. Actually, wait. Is this the collision time? I don't think so. Because that's 30 milliseconds, right? I think the collision time has to be less than... Right? How many milliseconds do you think a ball...
I feel like that would be the collision sign.
You think so?
Jay,
have you done impulse? Have you done impulse, Jay? Is that a thing? I'm just curious. But then here's the interesting thing here, Breskles, right? So if I do have oh man, this is super fucked. Average acceleration in a certain amount of time. But then don't I need the mass of the ball too? Or wait, could I say this? Could I say this is equal to mass times A average? Delta T is equal to M delta V.
It might just be a kinematics. I feel like it just...
I think it's just kinematics. I think we're overthinking it. I think we're overthinking it. Because then you get the same thing. Do you see how you get A times T is delta V? It's the same shit. Okay.
Yeah.
All right, we're just overthinking it.
Oh, no.
I don't know why the W's west, Fembox, apparently. Okay. I think the answer is just multiplying these two things together. So let's just get you a number. You tell us whether this is the correct answer you're supposed to get. I'm curious, Jay. E minus 2. Yeah, 42. And this seems correct to me. Like 42.7 meters per second is like 70 miles an hour. Yeah. You let me know if that's correct. I think it is. We could also like throw this at chat real quick. Yeah, 42.7. Cool. Yeah, they just use the kinematics equation. Okay, cool. I agree with that. Good question there, Jay. Appreciate it. Not too crazy. You're welcome, Jay. So, Jay, if you want to get credit for that question in our Discord, because we give out prizes if you ask enough questions, we will post it here in our Discord here. Let me see. You were submission 5. Let me mark that as 5. 5, I'm going to post. I'm going to delete. So that'll come up right here. And then we'll dump the screenshot in. Great question. So just go like react to this or something if you want, and I'll know who to give points in our Discord to. You're carrying me my calc and vectors class? Cool. Glad I'm helping. You're just starting limits. Uh-oh. Yeah, limits can be tough. Okay. Yeah, let me put some more time on the clock. I wanted to go to the gym today, but that's probably...
Top 3 limits suck. There's no L'Hopital's in top 3.
L'Hopital.
Unless you can get into a single coordinate system, but that's a pain in the ass.
Okay. There. I'll put enough. Put another 30 on. All right, let's see. Don't go, Dr. Gold. We're having fun. Oh, good job. I'm glad you guys are having fun. But I need to exercise.
You are.
Right.
Your brain's a muscle.
My brain's a muscle. Yeah. Oh, you know what I really want to do? I have a coupon for a Jack in the Box free Jumbo Jack burger. But I won't let myself get that unless I go to the gym, because otherwise I'm just getting like fat. Let's go choose a winner. I think the Jumbo Jack got voted as like one of the best like cheap burgers that are out there.
At this point, if it's like sub $5, it's like, I don't know, care how it tastes.
Yeah, even In-N-Out, dude. I get my standard 3x3, bro. It's like fucking $10 these days. Do I do high school calc? Yeah. You don't have In-N-Out right where you are, right?
No, I'm just like 2.5 hours away. But I had one back where I lived in Colorado, and so when I went back up there for a week, just the entire week, I was eating In-N-Out because I was.
Oh,
like,
it's so good. The burgers are good. The fries are trash.
Appreciate it. I kind of like their fries.
No, their fries are trash.
Weren't too bad.
Trash.
The first burger they gave me though was just like it was like a fucking Saturn burger. All the onions were the same size, and they were like slightly bigger than the patty. So
oh,
like,
I love that.
It was just
yes.
a bunch of onion.
Dude, hell yeah, onions are great. Okay, what's up, Tuma?
Hello.
Yeah, how's it going, dog? How's your test? Did you have a test yet, or you have a test coming up, or like what's up?
It's next week, but
this stuff's hard. You're not doing well physically?
Oh no.
Oh no. Are you like sick?
I just got my bottom 2 wisdom teeth removed.
Oh damn, dude. Yeah, the wisdom teeth. Yeah, those suck, dude. Oh yeah, because you said you were about to turn like a certain age and then you can't get them pulled out anymore or something. Yeah. Okay. Well, let's try to take some of the pain away of doing some. This is Calc 3.
No.
So. Oh, sorry. This is Calc 2. So yeah, Jay's asking, do I do calculus questions? This is a calculus question. It's second part of calculus, but okay. The equation r is equal to 2h cosine theta plus k cosine theta to rectangular form. Verify that it is the equation of circle by writing it in standard form. Okay, cool. So, excuse me, sorry. R is equal to 2h cosine theta. Or can I just move the r over 2 on the other side? Let me just do this. H cosine theta plus k sine theta. So if we convert it to rectangular form, oh, I know what I'm gonna do. I'm gonna multiply both sides by r. Let's do that. Multiply all this shit by r, dude. Okay.
Oh.
Yeah. When in doubt, just.
So you can put the x squared plus y squared.
Yeah, watch. Yeah, because this is gonna be h r cosine theta plus k r sine theta, I guess. Yeah. And then this right here is x.
X and then plus y.
Good. And then this is x squared plus y squared, I guess, right? Okay, so I have x squared plus y squared all over 2 is equal to hx plus ky. I just left the v in the Monte Carlo integration in my exam. I just hope I get partial marks. I hope you do too, random dude. Monte Carlo, that's intense, dude. What? Okay. Now, this is where we're going to do completing the square, right? So, I'm going to move all this shit over. Because, sorry, what do they want? Yeah, they want the radius in the center. Okay, so watch what we do here. So, I'm going to say x squared. I have to put a 1/2 outside, right? So, x squared minus 2hx. Okay, we're going to leave that. I'm going to say plus 1/2 y squared minus 2ky. And then we're going to say all this shit is equal to 0. Do you understand why I put the 2 on these now? So I move this over so that I had like 8x squared over 2 minus hx. But when completing the square, you don't want anything on here. So what I'm doing is I'm pulling out a 1/2. So pulling out a 1/2 is the same thing as like multiplying I guess everything by like 2 over 2, right? I think is one way to think of it. Well, no, I don't want to do that.
Did you factor it out?
I just factor out the 1/2. Yeah, that's what I'm trying to say, sorry. So I just factor out the 1/2, but when I do that, I have to put a 2 on this, right? In order to get my original thing I wanted. Right? Okay. So then I did the same thing here, right? For the y, okay? So now I gotta go complete the square, which is very related to what Jay was asking for earlier, right? So completing the square means you take whatever the coefficients are here and you divide them by 2. So that's just gonna equal to h. And then you square that and you add it and you subtract it. And so here it's gonna be plus h squared minus h squared. And then it's gonna be the same shit here. This is gonna be plus k squared minus k squared. Or not ky squared, sorry, just k squared. Does that make sense?
Yeah, you're doing the, what do you call it?
Completing the square.
Yeah, completing the square.
Good. Okay, so then all of this is going to become x minus h squared. And then I still have a 1/2. And then the key thing is, even though this stuff becomes this shit, the 1/2 still has to go through and multiply by this. So then this is minus 1/2 h squared. Okay? And then we're going to do the same thing here. This is going to be 1/2 y minus k squared. And then that's also going to be minus 1/2 k squared.
Oh, you just multiplied the 1/2 in?
Yeah. But then here's the cool thing. Do you see how there's a 1/2 on all this stuff? So I can kind of just get rid of them, right? Yeah, let's just get rid of it. Yeah. That goes away, that goes away, that goes away, that goes away. Because I can always just divide. And then I have minus h squared minus k squared. So those things are going to go over. Because those are constants. Those are just numbers. And then I'm going to get x minus h squared plus y minus k squared is equal to h squared plus k squared.
Oh, you just added the h squared and k squared to the right
Yeah,
side?
right. Because this is the general form, right? Where now this is r squared, right? The vertex is already there, right? The vertex is h comma k. It's hk. H comma k. Because that's in the right form. And then the radius is equal to the square root of h squared plus k squared.
What threw me off was the h and k.
Sure. Yeah, this shit right here, right?
Yeah.
Yeah. I think the trick here, you know that the regular equation of a circle at the origin is x squared plus y squared is equal to r squared? Right? So, you know you kind of want an r squared or something squared somehow, so that's kind of like why I just multiply this by r to get r squared. But then I'm like, oh, but I also need x squareds and y squareds now, but I can convert that r squared into an x squared plus y squared. And then these will be terms of x and y. Like, when I got to here, when I got to, like, this part right here, I said, oh, wait a minute. If I'm trying to find the equation of a circle in standard form, I need x squareds and y squareds, which I can get from here. You get a little annoyed here because you're like, wait, but fuck, I also have, like, regular non-squared x's and y's. But then you remember, oh, if I put those over, I can start completing the square, and I can create something cool. And then whatever the other, like, I say, like, you know, remains of, or like the leftovers from completing the square, those all are just going to get moved to the other side and become r, or become r squared.
But hold on. Once you got rid of the trig, isn't it basically already in rectangular form?
Right here?
Yeah.
Yeah, I mean, it's in standard form, I guess. Well, no, wait, what the fuck is standard form for a circle?
It's what you put it, the x minus h squared.
Yeah.
Plus y minus k squared.
What's the other?
The h and the k are technically the horizontal and vertical translations.
Yeah. Wait, there's a difference between general form and standard form, though, right? No? No, they call this... No, you're right. No, you're right. Yeah. I get confused because there's this form, which is ax squared plus bx plus c is equal to 0. Like, this is called, like, standard form... Sorry, okay, this is standard form for a quadratic. Okay. So, I don't think this is what you want.
No, that's like I think it's sometimes called general form.
Maybe this is called general form then.
Yeah, that's not what you want to go for in the
exactly
circle. If that was something like a kind of like weird, ugly, like hyperbola or something like that, then maybe you would want to use that form.
Yeah.
But as for like a circle, you have that standard form with the H and the K's because it does a very good job telling us specific things about our circle.
Yeah, where it is, yeah, for sure.
So it just wants me to rewrite it in that form?
Yeah. Yeah, this is the form that we want you to rewrite it in.
It's like a whole puzzle, man. That's so, like...
Yeah. Dude, I fucking love puzzles, though. I think this is so fun. I love math as a puzzle is dope.
That's dope.
It's fun when you're not doing it for a grade.
Yeah. Yeah. I don't know, dude. Yeah, I get it. Or when your fucking wisdom teeth have been pulled out.
Oh, no.
Or when it's a problem Breasticles has given me.
Emotional, damn it.
I have to remind you of what, like, calc students feel.
Let me remind you of what the pain is. Okay. Does that make sense? Tombs? Yeah?
Yeah, it makes sense.
Okay, cool. Great. Good job. I hope you feel better. Tuma. Oh, nice, Jay. Good job joining our Discord. J Prime. Oh, that's a cool name. J Prime. Nice. Here, let me give you a coin for that. And amount 1 to J. Boom, 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 boom. Nice. Okay. And then let me put Tumas in there. Let me see. Mark done. Oh, I got 15 minutes left. Okay. My self-imposed deadline on myself.
I actually had a quick question.
What's up, dude? What's your quick question?
So
yeah, here we go.
Placed it right here.
You always know how to sneak in you know how to sneak it in. You're just like,
No,
dude,
you don't have to solve it.
This is like just the tip of math, dude. What? You're gonna take me to dinner first, dog. What the fuck?
I'm struggling, bro. I just had a question. You don't have to solve it. You don't have to solve it. I just wanted to know, what do they mean, like, find an interval over theta where the graph is traced once?
Okay, let me see. Okay, sorry. Okay, alright. Use a graphing utility to graph the polar equation. Find an over for which the graph is traced only once. Oh, okay. So in my mind here, r squared is... So usually when you graph stuff, you're gonna start at like some value of theta and you're gonna go this way and you're gonna see like what you would get, right? This one is weird though because, okay, well first of all, r squared could never equal something. Well, we're not gonna have negative stuff either. But yeah, yeah. Okay, so you can start marking some things like no. Disqualified. Because r squared has to be positive, right? Do you see how like theta can't be negative? So this is automatically like, nope. This is no. Okay. So then you got to think about, okay. So as theta goes up, this is going to go down. Right? Do you see that? Like as the angle goes up? Fascinating. But then it's like plus or minus. Because, like, watch. If theta is equal to pi over 4, for instance, right? Pi over 4 would be over here. Then I know r squared is equal to 1 over pi over 4, which is equal to 4 over pi. And I don't know. I'm going to call that about 1. right? So r squared equaling 1 means it would map out the point here at 1, but it would also map out the point over here at -1. Because do you see how -1 for r also gets you this value?
I'm still not sure what it's asking for.
Well, okay, so here's what I'm seeing is that, like, as you start increasing theta, right, you're always going to be mapping out the one opposite to it. And you don't want it to cross. So, let's see. And also, as theta goes up, this gets smaller and smaller, right? So, r starts out big, and then it starts getting small, and then it starts getting even smaller, and then it's going to go even smaller. It's eventually just going to, like, just spiral down to 0. But I think because it always plots the opposite one on the other end. Oh, fascinating, actually. This is going to happen. But, okay, so when we're here, we're also going to plot here. I'm trying to think, like, how this looks. Oh, shit. Dude, what? How does this even look, dude? What the hell?
Oh, no.
Like,
I don't think it hits itself. I don't think it hits itself. It doesn't hit itself. Yeah, so I think it's 0 to infinity. I think it's 0 to infinity.
Yeah, just plug it into Desmos.
Yeah.
No, it should be 0 to infinity, not including 0.
Oh, not including 0? Oh yeah, you can't divide by 0. Oh wait, that's not a solution though, dog.
Maybe it's 0 to 2 pi?
I guess including 0.
I guess you include 0 because your infinite, your radius would just be infinite.
Yeah.
Let me try to do that.
So.
R
to the second is equal to theta. Is that what I say? Well, it doesn't. It doesn't.
It makes you do
trust me.
square root.
You're not
Yeah,
that guy.
R equals square root of 1 over 2.
Oh, okay. So r is equal to yeah, plus or minus, right? So I'm gonna say square root
Oh, it's right.
of theta. Yeah, it's that, right? So that's the positive one, and then you have r is equal to the negative square root of theta. Dude, what?
Never
One divided by. 1 divided by.
Oh yeah, never mind. Dude, this looks way cooler though. I like this. Okay, whatever.
So it never crosses itself.
I don't think it does. Yeah, that's actually that. What? Whatever. That's really cool, actually. Wait, can you just divide this?
If you highlight it and then press divide, it should do it.
Really?
Alternatively, you could just use a negative.
I'm just gonna fucking rewrite it. Okay, there we go. Dude, this was so annoying. What? Desmos, you silly goose. Okay, there you go. Yeah. All right, so they just do this. Do this. All right. We're just gonna go down the wormhole, dude.
Yeah, so I guess negative infinity to infinity then.
Yeah. No. It can't be negative. You can't take the square root of a negative number. So it's 0.
The answer was 0 to infinity.
Yeah, it's this one.
Oh, yeah.
That's super cool. It's kind of weird.
Yeah, it was a weird
Yeah,
concept
you have
at
to graph.
first.
You have to graph. I was trying to do this in my head, and I'm just like, oh shit, it's like doing stuff. Yeah.
I'm surprised you even got like what it looked like. That I don't know how you do that.
Oh yeah. All your calculator thing is doing is it's plugging in it's going around. Like it's doing this. It's going around. You know, this would be like 0, pi over 2, pi, 3 pi over 2, 2 pi. It just keeps going. It just keeps rotating around, and then it calculates like how far away from the center you're supposed to be.
But did you like plug in values in your head?
Yeah, that's what I'm doing. Yeah.
Oh,
Yeah.
damn, that's impressive.
Oh, it's not too bad. I mean, you just see here, right? Look, that like, oh, r is going down as theta goes up. So that tells me when r is 0, my radius is like infinite. But then as I increase, so when theta is 0, my r is infinite. But then as I increase theta, because I'm going around counterclockwise, my radius needs to start coming in. So like when I'm here, I'm closer. 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 And it just keeps spiraling.
Oh, I see.
Yeah.
Yeah.
Okay. Is that the last one you had questions with, or do you want to go to like one more bar? So like,
it's okay.
He's like, nah, let's just go to one more. Just one more drink. One more drink. It's okay.
It'd be unfair to others.
Yeah. Let's just cuddle.
Let me hire you as a tutor.
I'm free right now. But yeah, okay, cool. Yeah. Feel free, come by, submit questions. You can also submit multiple questions in the queue now if you want. It slows down the votes. Let's do wasabi snooters in the parking garage. Damn. Fucking, that's a classy date sensation. What? Wasabi snooters? Alright, cool. Jay says, can you explain how someone can eventually like math just as much as you do and find it enjoyable? Ooh.
I have the easy shortcut answer. Autism. I can say that because I am.
I can say that. It's a spectrum. We're all on the spectrum, dude.
Yeah, exactly.
Just pretend.
Just pretend. No, I will agree. Tuma is kind of correct that I enjoy math now because it's not for a grade. So if I don't understand something and I'm confused, I don't get upset that it's going to harm my life because this is all just like for funsies. I think there's a really cool thing. Her name is Tiny Toxic Tofu. I went on her stream once actually to do a podcast episode. She's really cool actually. She's a physics streamer. But she had this really good post here where she said there's a difference between learning physics and studying physics. So when you study physics, you're more concerned with, can I do the questions? Can I pass the test? Can I do the problems? You don't care as much why things work. You just care that you can get them to work. So that's like studying a class. But if you're trying to learn physics, or in this case, learn math, you're trying to understand why things happen, and it's okay if you don't, and you're comfortable with asking questions that like, I don't know this stuff. I really liked this post from her. I was like, yeah, wow, there's a difference between studying and learning. So I would say what we're doing now is more learning, but what you do when you have a test is you study. I think. Yeah, right? Kind of makes sense.
Yeah. I think that's what everybody naturally thinks.
Yeah. Okay, let's see. What are the other questions? Dude, what the fuck? If F is holomorphic on U, continuous on the closure of U.
Oh no. Yeah, I'm pretty sure that's like modern algebra.
Fucking trolls. Okay, here. I'll do DM's graders. I'm not even gonna spin the wheel just because I have 5 minutes left, and the other ones are troll questions, right? Yeah. Like, what boobicles is this one? If you repeatedly add a number to its reverse, you eventually get the palindrome. If you start with 89, how many steps until you get the palindrome? Is it gonna be 67 steps?
Oh no.
It's actually 24. Yeah. I was like looking for the troll part of it, and it kind of resembled the like boobs in a calculator that you do in like middle school, but not like that close.
Boobies.
Really sure. Yeah.
Boobsicles. Okay. Yeah. Here, I'll show this one to you, Blue. We've done a lot of completing the square today, but this will kind of make sense, right? It just takes forever. Oh, that's the point. Okay, cool. So again, divide by 2. 10 over 2 is equal to 5. Yes, Lucky Cat, if you have an actual question, you can submit it. But I am going to go in 3 minutes. Or you can just ask me in the stream. It's okay. All right. This squared, so that's going to equal to 25. So then you're going to do add 25, subtract 25. This is x squared minus 10x. And actually, I don't like to actually do the squaring. What I'll do is I'll leave it like this. And I'll just say plus 5 squared minus 5 squared. And then you have minus 6. The reason why we do this, let me just kind of show you like why it works. Okay. So for instance, you should know that if I do x minus y squared, this is the same thing as x squared. And then minus 2xy plus y squared, right? So what you're doing when you're completing the square is you're forcing this thing, right, to now divide by 2 and square. So this 10 is now the same thing as 2 times 5, right? Just by definition, whatever number you put here and you square and you add, twice that number is what you had in the middle. And then you should notice, right, that there's some similarities here. Look, x squared, y squared, in this case, is your 5 squared. And then you notice how the middle term is now 2xy, right? Look, there's y, there's the 5, there's the 2, and then there's the x. So this will this forces this to look like this, which is called a perfect square trinomial. So perfect, whatever. And then that comes to be a nice binomial squared. And so that's why this whole thing... Some people, they just learn... They get taught completing the square, and they don't ever really get shown that, like, why this turns into this, which I think is important. Maybe that's the difference between studying and learning again. So this ends up becoming x minus 5 squared. It's always this thing, and then this plus or minus is whether what this thing is plus or minus. And then that becomes minus. Now you can square this out. So now it's minus 25 minus 6. And so that would just become minus 31. Oh, I get the theory. I just knew it worked. Yeah. Okay, good. All right, there you go. Cool, Blue. All right, so it's x minus 5 squared minus 31. Your vertex is at 5, negative 31. And yeah, that's it. Cool. Okay, cool. Good question, Blue.
That's Dave.
Why does it turn into that? Yeah, no, it's cool. It's a fun thing to understand. Demonstrator. But nice, Blue. I hope that makes some sense to you. I know you were wondering about like earning bond coins. Here you go. This is how you get bond coins. You just have to ask questions during the stream. That's all you gotta do. Hopefully there are things like you actually want to learn. It's useful. Visuals, it being negative tripped me up before. Yeah. The other way to remember that is that technically x plus y squared is equal to x squared plus y squared. Sorry, x squared plus 2xy plus y squared. If this y is a negative number, like in this case where we had x minus 5, that's the same thing as saying plus negative 5, where y is negative 5. Whenever you square these things, the negative is going to go away anyways, but then the negative will show up here. And that's why this thing ends up becoming minus, because your y was negative. Your x is always assumed to be positive. Okay. Let me see. I do have to go, but Lucky Cat, I'll take a look. Yeah, let me look at this real quick. Intensity? Okay, this is logarithmic. What is the magnitude of an earthquake that's 10 times as intense as a standard? Is magnitude intensity squared? Or is magnitude squared equal to intensity? Or, it's probably logarithmic because it's Richter scale.
Yeah, I want to say it's like log 10 or something.
Yeah, I think it's something like that. Fuck. Ooh, energy equivalent, dude. Where do they put this, dude? Where are these forms? These things. Intensities of shaking. Okay. Measured on the Mercalli scale. Oh, I don't know.
I found it. It's
What is it? Is it log? Is it like decibels?
Yeah, it says M equals log base 10 of A over A naught.
Okay.
M is magnitude, A is the amplitude.
Yeah, so it is decibels basically.
A naught is baseline amplitude.
Okay. Yeah. Okay. So this is. So here, let's leave this as. Yeah, it's basically like sound, which I have to teach this actually during my class over the summer. Okay, so what's the magnitude of an earthquake that's 14,010 times as intense as a standard earthquake? I assume they say this is a standard earthquake then? Maybe? I don't know. Okay, so M is equal to the...
Yeah, I'd assume so, because that's supposed to be like the baseline amplitude.
Right, it's the same. When you do decibels, it's the minimum intensity that I think your ear can hear is what I0 is.
Yeah, it's the minimum that your ear can hear, and then...
Yeah, like physically or shit, yeah.
I forget exactly what the other ones are.
So you just do log of 1410. That's equal to 3.14. Wait, it's almost pi. Okay, so you can say 3.14 times as intense. Cool. All right, nice. Good question there. Pineapple, that was fun. Can you ask how old I am? 36. Nice. Okay, that's it for today, so let's close the stream. All right, thank you everyone for coming at Actual Education Office Hours. Appreciate all the things you guys have done, all the questions, super fun. Our next stream is not gonna be tomorrow, right? Tomorrow's Wednesday. Okay, so yeah, if you ever want to figure out like when we're streaming, the website for that is actualofficehours.com. You're very welcome. Sorry, I've got to put pineapples in. There you go.
Where's the schedule for the streaming?
Good. Yeah. Yes. Good. Tuma. So if you go to www.actualofficehours.com, or I put the link for you there. If I put exclamation point submit, hit here for streaming schedule. These are all the different streams that are happening. So looks like yeah. Well, I thought Penn Center was going to do math help tomorrow, but this updates pretty rapidly. So Penn may have changed his mind. So it looks like Zach's doing differential equations curriculum tomorrow from 11 to 2 my time. You'll see this in your time zone as well if you check it. But also I know at the end of Zach's stream sometimes he does field questions. So if you want to ask Zach math questions, you can always kind of just like hop in his stream and be like, hey, would you help with some math stuff? Sometimes he is looking for stuff to help if you want to get help from him. Otherwise, our next stream for homework help will be on Thursday, an hour earlier. And then go join the chess tournament. That'll be Friday at 5 o'clock Pacific. So we'll have fun to go do that. Okay. Awesome. All right. Let's go raid someone. Tuma, I hope your teeth feel better soon. That's no fun.
Thank you. Yeah, it's difficult.
It is. Did they give you painkillers at least? You get some oxys or something? Or like what?
They didn't do it the first time, but I think the bottom two, it requires more surgery. Like you cut the skin.
Yeah.
They did give me.
Nice. Yeah. Just go get. Just go vibe out, dude.
Talk.
I know. Well, you're doing the Lord's work, talking enough to learn math in your condition. Let's see. Nerduino's doing a 4-year stream anniversary. Oh, let's go say hi to Nerduino. Congrats, 4 years. That's awesome. Okay, cool. All right. Go say hi to Nerduino for me. Enjoy the rest of your day. We'll see you on Thursday. Peace.
It's very regular, and their regularity is related to the brightness of the star, so... Oh my goodness, so many raids. Actual Education, welcome in. How you doing? Zevstar, welcome in. Good to see you. Raiders, thank you so much, Actual. Yeah, 4 years, man. Crazy stuff. Thanks, Zevstar. Nice. Guys, welcome in if you just came in on the raid with the Actual. Guys, make sure you're following Actual Education. Another great streamer here on the platform. I'm gonna do my spiel real quick. If you don't know me, I'm Nerduino. I'm an astronomer, and I worked at NASA for about 10 years. I stream on Twitch Tuesdays, Thursdays, and Sundays at 6 p.m. And we talk about space, astronomy, the latest research and papers. We were just looking at a new paper on planets around binary stars, so like a Tatooine kind of a deal. That was sort of